For centuries, Plato held a firm grip on how we understand mathematics. He assumed that numbers and geometric shapes exist as independent, immaterial substances. They live in a separate realm of perfect, abstract forms, completely detached from the physical world. In the medieval Islamic world, thinkers began to dismantle this idea. The 11th century polymath Avicenna, or Ibn Sina, examined this Platonic realm of forms and rejected it as a logical fallacy. Avicenna pointed out a fatal flaw. If a separate, immaterial triangle is the cause of a physical triangle we draw on paper, they must share the same essence, the property of being a triangle. But if they share an essence, the abstract triangle itself needs a cause. It requires another perfect triangle to explain it, and that one requires another, creating an impossible infinite regress. To resolve this, the 10th century philosopher Al-Farabi positioned mathematics somewhere else entirely. He argued that mathematical objects occupy an intermediate state. They are abstracted from matter in our minds, but they do not exist independently of it. This prompts an obvious question. If the perfect circle and the number 4 do not exist in a mystical realm, where exactly do they live? And why should we trust the equations built from them? Instead of looking up at the heavens, these scholars looked at the human body. They constructed a model where mathematics is extracted directly from physical matter by human cognition, keeping it strictly bound by physical and logical limits. By grounding arithmetic and geometry in physical reality rather than an ethereal plane, medieval Islamic philosophers redefined the limits of what could actually be proven. This physical model starts at the eyes. Medieval Islamic epistemology dictates that no mathematical concept can be grasped without initial data collected by our external senses. When you observe two physical objects, that visual data travels along the optic nerves and pools at a cognitive intersection. Avicenna called this collection point the common sense, the first stop in a pipeline of internal faculties. From there, the data moves to the central mechanism of this philosophy, the faculty of estimation, or WOM. WOM is a cognitive function that observes physical things and strips away their specific material conditions. If you look at 3 wooden blocks, WOM wipes away the accidental properties. It ignores the color, the wood grain, and the weight, leaving behind only identical wireframes. It removes the specific material while maintaining the general condition of materiality. This process of abstraction is what allows the human mind to perceive non-sensible attributes. Our eyes see the wood, but our estimation perceives the geometric magnitude and the abstract concept of threeness. This observation led to 2 competing interpretations. Literalist philosophers argued that mathematical objects literally exist as properties embedded in physical matter. Abstractionists argued that these objects are entirely mental constructions, built by the brain using physical impressions. In either case, anchoring mathematics to this biological, physical pipeline solved the ontological problem. A separate, perfect Platonic world was no longer required to explain how we know what a triangle is. Relying on human biology introduces a severe risk. If our mathematical concepts come from imperfect physical senses, how do the foundational axioms of math achieve absolute, indubitable certainty? Avicenna addressed this by dividing foundational mathematical truths into 2 categories of certainty: awaliyat, which means primary data, and fitriyat, or data with built-in syllogisms. A syllogism is simply a logical argument that uses 2 premises to deduce a conclusion. Awaliyat are propositions that require no middle logical term. As soon as your mind grasps the concept involved, you are forced into an immediate intellectual agreement. No proof is necessary. The classic example is the statement, "The whole is greater than the part." Once you understand what a whole is and what a part is, your intellect treats the truth of the statement as self-evident. Fitriyat are propositions that do require a middle term to prove them, but that middle term is so obvious it snaps into place the instant you conceive the subject. Take the axiom, 4 is even. The instant you think of the number 4 and the property of being even, your mind immediately generates the concept divisible by 2. It bridges the gap automatically, proving the statement in milliseconds. Under this framework, mathematical certainty is not a mystical revelation. It is the mechanical output of a properly functioning mind accurately processing abstracted physical concepts. This strict requirement for physical and logical grounding restricted what mathematicians allowed in their models. Specifically, it was used to prove that an actually infinite magnitude is a logical impossibility. To test the limits of physical reality, philosophers like Avicenna and Al-Kindi favored a geometric proof known as the mapping argument, or Burhan al-Tatabuk. This diagram illustrates the mapping argument. We start with a premise. Assume the existence of an actually infinite line, AC, stretching infinitely to the right. At its origin, we mark a small, finite segment, AB. Now we remove the finite segment AB. This leaves us with the remainder of the line, segment BC, isolated on its own. Next, we create an exact copy of that remaining infinite segment, BC. We will designate this new duplicate as line B star C star. We then map this copy back onto our original infinite line, AC, by sliding it to the left so that point B star aligns perfectly with point A. Because both of these lines extend infinitely to the right, they correspond to each other perfectly. And according to Euclid's fourth common notion, things which correspond to one another are equal to one another. But this creates a fatal contradiction. Line BC is just a proper part of line AC. It is physically missing the original segment AB. Yet, according to the geometric correspondence of their infinite ends, they are mathematically equal. This directly violates Euclid's fifth common notion, which states that a whole part equality is absurd. This logical collapse proves the initial assumption false. Within a mathematical system grounded in physical estimation, actual infinite magnitudes cannot exist. This leaves one final piece of skepticism to address. If mathematical objects are ultimately just mental constructs derived from physical estimation, why is mathematics so reliably accurate at describing the external universe? To stabilize this system, later scholars introduced the concept of nafs al-um, which translates to the thing itself. It acts as a standard of objective truth that exists beyond the individual human mind. Relying on this concept, thinkers like al-Jurjani defended a position known as judgment realism. They argued that even if numbers and geometric shapes are imaginary constructs of the brain, the mathematical judgments we make about them correspond precisely to objective reality. Unlike modern mathematical Platonism, which insists that numbers actually exist out there in the universe, the Islamic model achieves a unique balance. It recognizes math as a cognitive process without sacrificing its universal validity. The architecture is complete. Sense perception feeds the faculty of estimation. Estimation extracts the concepts to yield self-evident axioms, and those axioms are used to define the absolute limits of the physical world. The philosophers of the Islamic Golden Age built a foundation for mathematics that required no mysticism and no ethereal realm of perfect forms. They relied entirely on the rigorous application of human faculties to the physical world we actually inhabit.